GM, welcome everyone. Welcome to this new first flight. Today we are going to have a really interesting project on which we are going to delve into the flash loan world. My name is Vasiliy, I'm a developer advocate at Cyfrin, and today I'm going to be your host on this first flight. But before we start, for you peeps that don't know what first flights are, these projects are our effort to bridge that gap between experienced auditors and newcomer ones. You know, participating into a competitive audit contest is the easiest way for you as newcomers to start learning, growing, networking, and getting feedback on your research. But when everyone starts on this, we all feel this imposter syndrome, right? You don't know what to do. You think that maybe the projects are too complex and you're not going to be able to find anything, and you don't stand a chance with the other more experienced auditors, right? So first flags are our effort to break that bridge and make competitive audits more affordable and easier for newcomers. Also, this is the best way you are going to have to learn and understand how to become a better auditor. However, on this week project, we are going to have our most challenging project yet. This project is going to be almost 3 times harder than our last first flight, and we are going to have really interesting things going on. So to start with this, let me share my screen and we can go through this project. Let me just share it over here. Okay, this project is called Thunder Loan, and it's for you to become familiar with the DeFi flash loans. Of course, this project is not going to be as harder as an actual audit for a big protocol, but as I said, this is going to be at least 3 times harder than our last projects. So if you go back here, you can see that the EN slug, or the number lines of code we have, it's almost 400, and the complexity score is more than 300. And if you have participated on our last week first flight, you are going to see that this is 3 times harder. So to give you some context about what this project is, let's go to the description. So basically, this is for you to be able to understand how flash loan works and, of course, audit that project in order to find some juicy vulnerabilities, right? So basically, this project will allow you to do 2 things. First, for the peeps who want to put their assets into a liquidity pool, they are going to be able to put those assets, and then the protocol is going to return as gratitude or as a compensation an asset token. So basically, you can put your assets into the liquidity pool, and then the protocol is going to give you the asset tokens as interest. And the more people borrow from the protocol, the more interest you are going to gain. In the other hand, we have the people wanting to borrow that money. So a flash loan exists only in one transaction. So you can borrow any amount of assets you want, and you have to repay that on the same transaction. However, this might seem like kind of weird, right? If I have to pay the whole assets in this single transaction, why even bother to at first start getting those assets, right? Well, flash loans are really useful for different use cases. For example, the most common use case is arbitrage. You know, different exchanges have different exchange rates between assets. So for example, you can take a flash loan on one protocol, sell that same asset on another protocol with a different exchange rate, repay that loan, and you can take with you home the remaining of the earnings. Also, you can use flash loans for different use cases as liquidate as liquidators. For example, if someone have collaterals on another protocol and they don't have the ability to repay those collaterals, you can void that liquidated collaterals. And well, there are a lot of other use cases you can definitely research. Basically, this is how this project is going to work. However, we are going to have another layer of difficulty because we have another contract called Thunder Loan Upgraded. We are going to discuss this a little bit later. So let's get started with this. Of course, as most of the projects, you are going to need to know how to use Git. If you don't know how to use Git, what are you waiting for? Go and check out Patrick Collins' courses on YouTube. They are free, and you are going to have the ability to learn how to use Git, at least on the basic level. And we are going to use Foundry. Again, if you don't know what Foundry is and you don't have any experience at all with smart contracts, go to the Foundry course, 100% free on YouTube by Patrick Collins, and you're going to learn everything you need to know about Foundry. So let's get started with this project, shall we? First of all, let me clone the repository. So let me open then my terminal. I have it over here. And let me paste this. So git clone and the repo name. The next thing we always have to do is to go to that folder, and then let's hit on make. This is going to compile all the project. This might take some time, so let me check if everything is going fine with the live stream right now. And yeah, then here we have a comment, and it says the first two were relatively easy. This one is way more complex. Yes, it is, because in the other ones, the scope of the projects were just one smart contract. Here we have different smart contracts, and these smart contracts interact with each other. So yeah, this project is kind of more complex than the other ones. Okay, this finishes. Let me clear this. And now we can start working with the code. Basically, what we use mostly on the industry is Visual Studio Code. So let me open my Visual Studio Code here. And here I'm going to have the project. You can always check the README file over here, which is going to be kind of the same as we have on the Codehouse page. And basically, this is the scope details. It means that you need to check and audit all of these smart contracts in order to be able to search that vulnerabilities. Of course, we have other details like the ERC20 token standards that we are using comes from OpenZeppelin, but the ones who doesn't are specified over here. We have the roles, and we have these known issues marked as known. It means that this smart contract is safe. Of course it's not. We put a lot of bugs and vulnerabilities here. And when I said we, I mean Patrick, because he created this code base. So basically, the first thing you always need to do here is go again to your terminal and use your forge tests command. So let's hit enter. We have some tests here, all passed. Let's see the coverage we have on this test. So forge test, so forge coverage, sorry. And here we are going to have the information of what the tests are covering. For example, you see that deploy script are not covered, and the reason is because, first of all, this is out of scope, so we don't care about the deployment script, but the other ones have different colors and different coverage. So you know this as a token, the Oracle upgradable, and the Thunder Loan has yellow. It means that they don't have enough tests. You should actually go to the test folder. So for example, go to test, go to the unit testing, and you can here start writing your own test. So one of the most common questions we have always on these projects is where to start. I have different smart contracts over here, right? Where to start looking for bugs? So one of the most common tools we use, usually when we start making this auditing process, is an extension for Visual Studio Code called Solidity Metrics. Don't forget, you can always go to the extension store, type Solidity Metrics, install it, And once you have it, you can go to your code. And for example, for this asset token, I can just right click and solidity metrics. This is going to create for me this interesting report on which I'm going to have a lot of interesting information about this smart contract. Starting with the lines of code, the comments we have, and also the complex. This, especially this smart contract, doesn't have a real complex score, but the other ones does. And we are going to have really interesting information over here, like graphs. We can always know, for example, how many imports we have, how many public functions, how many payable functions, etc., etc. But one thing really interesting for us is if we go back to the bottom, we have these graphs. First, we have this inheritance graph. So we know that this asset token is a ERC20 token. Again, you can start working with this to actually understand how this actually interacts with each other. And we have this call graph. So we have all these functions this smart contract is using. So for example, if we have a problem, a vulnerability with the total supply, it might mean that we also are going to have a problem with the update exchange rate. Again, these are really interesting tools. For example, you have also the mutability. You can always know which variables can be changed and which ones doesn't, and a lot more information. However, as I said, there are another complexity layer on this project, and this is this, let me go to it, upgraded protocol. And yes, we have this really interesting and amazing ASCII art. You can erase it, but honestly, who would want to? This looks amazing, but well, never mind. You know, one of the biggest problems of smart contracts is also one of its biggest advantages, and is the blockchain is immutable. You know, if you send a transaction to the blockchain, you cannot change it. However, that also applies to the smart contracts. So if we know that this smart contract has some vulnerabilities on it, and we want to fix those vulnerabilities, how can we do it if we cannot change the state of the blockchain? Well, for that, we have something called upgradable smart contracts. And there are a lot of ways to upgrade your smart contracts. You have the social lead method, on which you say, okay, this smart contract doesn't work right now. Please don't use this smart contract address and start using this one instead. And then we have a lot of other patterns, such as the diamond pattern, the proxy pattern, on which you can upgrade your smart contract safely, and your users are going to keep interacting with just one smart contract address. Again, if you don't know what I'm talking right now and you are kind of lost about what upgradable smart contracts are, please go and check Patrick Collins' course on YouTube, on which you are going to have deeper information on how smart contracts and upgradability works. So we have this version number 1, let's say, of the Thunder loan. Here, we hope you find some interesting juicy bugs. And then we have the second version, Thunder loan upgraded, which is supposed to fix, quote unquote, some of those bugs. So we want for you to also take a look of this. How many bugs are solved in this upgraded version rather than the first one? And especially, does the upgraded version has new bugs or new vulnerabilities the first version didn't have? This is something you have to take in consideration. Also, if you take a look on the code, we have these comments over here as leader disabled. Next slide, reentrancy vulnerability. So wait, does it mean that we are spoiling the solution? We are spoiling where the vulnerabilities are? Well, kind of. You know, Slither is one of these static analysis tools that you can always use, and they are going to generate automatic reports. And if a leader is able to find those vulnerabilities over here, it means that they are, of course, not going to be on the scope of this contest. We want for you to think on creative ways to break this smart contract. So basically, once you understand all the code, once you have read all the README file and you understand what is the scope, what is the complexity, what is the smart contract supposed to do, now you have to start thinking, okay, how can I break this? How can I take this and make it work as isn't supposed to work. Once you have that, you are going to be able to start, scratching those juicy bugs. And well, I think this is more or less the summary of how this project is going to work, which are the scope, the complexity, and the smart contracts we expect you to audit. So I'm going to stop sharing my screen, and I'm going to see if we have any questions or comments here on the live. So, um, hmm. Oh, sorry, I have here a question saying, can you zoom a little bit? Yes, I can, but I think that I saw that too late, so I don't know which part you want me to zoom out. Let me see another questions over here. Okay, we have a really interesting question here. If a test requires an externally created smart contract, how to submit both tests plus smart contract as POC in a way that spurs the judge manual task, copy pasting, creating files, etc. Well, one of the things you have to take in consideration over here is that we need to make the judging life easier, right? So basically, I would suggest you to go to the core. For example, if you need to have like 3 different imports or 3 different calls to external smart contracts just to say, hey, here I found a vulnerability, I would say that you can improve that in terms of, okay, prove me that this is actually a vulnerability. So let me explain what I'm talking about. Let me share my screen again. Let me present over here. Give me a second, please. Okay, for example, here we have the actual repo. I'm going to zoom this in for you to be able to watch it easily. So for example, I'm going to say something just like random. If you have found a bug on one of these smart contracts, for example, on the upgradable, on the Oracle upgradable, the only thing we want for you to prove as proof of code is to take this line of code. You can copy and paste it, go to the submission page over here, and paste it over here. And now here on the description, you can prove why this is a vulnerability, why this line of code may cause a problem for us. And here on the description, you can see, okay, if you externally call this function from this place, this is going to represent a vulnerability and why. In these terms, you don't have to create a really big, complex submission or maybe submit different, as you said here, submit both test and smart contracts. No, you just need to point where the bug actually is. So here we have another question. So asset token is a wrapper of an ERC20 token with extra functionality. Yes, exactly that. If you take a look to that code on the smart contracts, the asset token actually imports from OpenZeppelin. We always use OpenZeppelin and as the standard for smart contracts. Let me also zoom this in a little bit more. And adding to the ERC20 token functionality from OpenZeppelin, we are adding some extra layers for that flash loan capacities. We have another good question here. What is the difference between a smart contract auditing and smart contract security researching? Okay, this is a great quick question, actually. Well, I could say that they are both related with each other because when you are auditing smart contracts, you are also researching from both and researching for vulnerabilities. But I would say the difference is when you are auditing a smart contract is because the protocol you are auditing for needs to know if that protocol has vulnerabilities, and this is going to be based mostly on your experience and your ability to gather those bugs. In the other hand, when you are doing smart contract security research, You are not especially auditing any special project, but you are making research overall on all the vulnerabilities. For that, you can go to pages like Solidit, on which you are going to have the information of the latest smart contract vulnerabilities on the space, and you can learn what went wrong on those protocols and how to improve the security on those. So summarizing, smart contract security research and smart contract auditing are related, but are not quite the same. Research is something you do all the time, trying to find new bugs, new vulnerabilities, trying to learn about what went wrong on other protocols. And smart contract auditing is when you put your efforts and times to actually go through a specific code base and trying to find bugs on that specific code base. Let me see, we have more questions over here. Hi, Vasily, Prime Kusan. Improving coverage is going to be a great way to start on this one, I suppose. Yeah, I agree with this. As you saw, the coverage on this is not too high. I mean, we are not even on green, so you might probably start writing your own test. For example, this one have just 36 tests from 64 potential ones. So you can start writing your own test for these ones as well. And maybe that's why you're going to start finding some bugs. And I was saying that without actually showing that to you. Sorry for that. Yeah, as I was saying, the coverage of this one is just 36 and the actual scope is 64. So you might probably start writing a lot of tests for the Thunderloan in order to find those interesting vulnerabilities. Anything else? Do we have any more questions over here? Well, I think we don't. GM. Yo, Patrick looks different today. Yeah, I'm not Patrick. Patrick is really busy creating some interesting upcoming content. So please be sure to check our social media because we are going to have interesting news soon. And yep, I don't think we have anything else. No questions for me. Gotta start with this one early. Yes, I agree. As this is harder than the other ones, I recommend you to start auditing this during the weekend because this is going to take more of your time. Let me check that. Give me a second, please. We have it here on the... Let me find it, please. 1 second. Okay, let me go with this. We have this question on, can you explain the deposit function, please? Of course I can. Let me go to that on the code. Please confirm that you are seeing this like properly on a big size. I can make it bigger if you want it. I'm going to say that it's big enough. So let me just add one more zoom, just in case. Okay, we have here the deposit function. Here you need to send the token. As you can see, this is an interface of a ERC20 token. The reason is because you can put as collateral a lot of tokens in the allowed list. As you can see here, we have here on the README file that this protocol supports these ERC20 tokens, so you can deposit any of these. Then let me go back to the code, sorry. Asset token, Thunder loan, yeah. So you need to specify the amount. And if the amount is 0, well, this is going to be reverted. So you need to create a new asset token. You need to take the exchange rate. Different exchanges have different exchange rates for each token. So you are going to get the exchange rate. This is from the Oracle. In this case, the Oracle is working like really easy. The actual Oracle you would like to use on these situations is an Oracle like Chainlink, price feeds in order for you to have actual price rates correctly, because if you have a centralized oracle, you're going to have like information which can be manipulated. Then you emit a event to deposit, which a new deposit is created. You mint the asset token. Remember, when you put your assets into the protocol is going to reward you with the asset token as interest, and then you calculate the fees. And well, we have other functions like update the exchange rate, because the exchange rate can change from this to this in just 1 second. So you update that exchange rate, and you make a safe transfer from the message sender to the address. So basically, you take the assets from the sender, in this case, the person who is putting those assets on the liquidity pool, to the token address and the amount the person is sending over. This function is actually kind of easy. Basically, what you are doing is just sending the tokens based on an exchange rate, and that exchange rate is going to come from the oracle, and the oracle is over here, the oracle upgradable. As easy as that. Yeah, I have low battery. I just connected my MacBook, sorry. Okay, I haven't audited a smart contract before. Can you give me some suggestion on getting started with auditing as a beginner? That's a really interesting question, and this is exactly what these first slides are about. As I said, when we started, when you start auditing, when you start trying to participate into a competitive audit contest, you feel this imposter syndrome, like, okay, I'm new in this, I don't know where to start, I'm not going to be able to find any bugs. And the reason is because we feel overwhelmed, right? We don't know how to do and where to start. So my recommendation for you as a newcomer who haven't audited any smart contract before is, first, you need to understand the basics. You need to understand how Solidity works. You need to understand how Foundry works in this case for this project. Again, you can go to Patrick Collins' course. And once you have those basics, you need to start thinking what this project does. For example, what we just said on this project is for the deposit function, right? And someone is asking how this deposit function works. So this is where you have to start. You have to start actually understanding what the code is supposed to do. This function is supposed to deposit some tokens into the protocol. Once you understand how the code works, once you understand what the code is supposed to do, the second step for you is to try to break it. How can I make this function to do something the function is not supposed to do? In that terms, you can start writing tests. If the contract or if that function doesn't have a use case, a potential test for a potential use case, you can start there. You can start creating a specific test for that potential use case that the smart contract creators didn't consider. And you can start thinking, okay, if someone uses this function in a way the function is not supposed to be used, they can break it and start like stealing funds. They can make a DOS attack. They can make a reentrancy attack, etc., etc. Now, if you don't even know what a reentrancy attack is, that's my second step for you. Start learning about smart contract vulnerabilities. Start learning about these problems in the industry. The best place for do that is go to solidit.xyz. Let me actually pin that on the comments. Solidit. And in Solidit, you are going to have like, give me a second, I'm just getting that. Okay, I have the link right now. So let me go here. Okay, sorry for that, for the delay. I'm just pasting this. So you can go to Solidit, and in Solidit, you are going to have the latest findings on the industry, the latest security breach, and the latest security vulnerabilities overall. So the more you start reading about vulnerabilities, the more you start learning about what are the potential risks and security issues, the more you are going to be able to identify those when you are auditing a smart contract. And my third suggestion for you is when you start with this, personally, when I start my first audit process, I wasn't able to find anything relevant. I remember that the only thing I was able to find was a gas optimization issue, which wasn't even in the scope of the project. So don't let that you to hold down. Don't let that you to make you feel sad or to make you feel like, okay, I'm not made for this. We all start like that. We all start like not finding anything, not being able to find any actual vulnerability, not being able to find any security issue. If you're starting on this, the most important is just submit. Whatever you find, even if it's out of scope, just look for it, research it, and submit. And once you start going from one competitive audit to another, to another, to another, you're going to start getting better. And when you get better, you're going to be able to find more vulnerabilities. And who knows, on time, you might be able to find a critical vulnerability no one else could find. And I think I take too much to answer that questions. So when you, okay, I have another. When did you actually started? Well, I started on Web3 space on 2020, and I did my first competitive audit actually less than a half year ago. So I'm kinda actually new on the competitive audit space. But you keep learning, you learn more every day, you go to Solidit and start looking for vulnerabilities, and in time you are going to go from an unexperienced newcomer auditor to a really good and experienced auditor. And yep, I think that we have it everything covered, and we are also running out of time. So thank you very much, everyone, for joining this first slide. I hope this give you the guidelines of what this first slide is about. I hope that this help you to learn how to start, like cloning the repo, go through the test using the extensions we used so far. And yep, that's it. Hope for you to submit any findings you have, and I hope you to find really critical things, really critical vulnerabilities, and really bad things to say about this code. So that was it for our end. Please don't forget to join our communities on Discord, check out Patrick Collins' courses on YouTube, and stay tuned on our social media to see more updates from us. See you on the next first slide the next week, and that was it for us. Enjoy your day. See ya.